Assalamualaikum and a very good day to the panel of judges and members of the audience. My name is IPM Biadi Sufianchan. Today I'm going to present the topic of IR 4.0 generation of face recognition based system. Moving on to the introduction part of this presentation, let us see the definitions of taking attendance. Taking attendance is a process of taking account the presence of individuals in class. Manual attendance systems have been applied here in Malaysia's education system from primary schools, secondary schools to tertiary education institutes. Manual attendance system is time-consuming process, especially in large classrooms. And attendance inaccuracy can occur either unintentionally or intentionally by the students. Even there are some advanced systems that are being introduced, such as QR code attendance system, barcode attendance system, and RFID attendance system, but the same old problem persists. In some cases, such as especially in barcode attendance system and RFID attendance system, new problem emerges as it is costly to install scanners in each and every classroom. This issue had led to the proposal of the face recognition attendance system, which is much more accurate and cost efficient, as the only equipment needed is the educator or the user's smartphone. Moving on to the system architecture, the system architecture can be divided into three parts: the input, the face recognition process, and the output. The input is actually the image capture or the image classroom uploaded by the user. The face recognition process can be divided into face detections, where it detects face in the uploaded image, face features extractor, where it extracts facial features from the detected image, face recognitions, where it occurs by actually comparing the extracted features in the image, in the captured image, and also the database. Next, the output of the system is attendance report. Moving on to the methodology. Methodology can be divided into four parts, that is database of face image, face detections, face recognition, and developments of Android application. Database of images here consists of 6 subjects from different genders and ages. Each subject's 20 images with face poses ranging from 0 degree to 180 degree rotations was taken, as shown here. The image was taken with a clear homogeneous background, where each image was given adequate lighting without any variation. This to ensure that there is no overexposed or underexposed region in the image. Then the image went through pre-processing step and changed the grayscale image. The changing image to the grayscale is to ensure the efficiency of the overall system. Moving on to face detections. Face detections, the main importance here is to locate and identify human face in digital image. If it detects any image, the system could crop the face from the captured image. There are plethora of face detection algorithms available in the market. However, the implementations of phylogenous algorithm was used. The reason why the implementation of phylogenous algorithm was used is due to 3 reasons. First, it is lightweight, has high rate of detection, especially in frontal face view, much more robust to different face views, especially compared to its predecessor. Face recognition is a classification problem where the objective is to classify the input face to the correct identity. There are many face recognition algorithms can be used. However, face descriptor feature extractor was used. Hot face descriptor recognize face by actually calculating the histogram of gradients in the image region. You can see that from the image below. The hot descriptor was used due to two main reasons. First is the robustness towards uneven illuminations and fast processing time with high true positive rate. This is good in applying it in real life situation. Moving on to developments of Android applications. Android Studio was used to design an Android applications which allow user to use their system anywhere and everywhere in the education institute. It consists of 5 pages and a navigation bar. The 5 pages are user registration, user login, the home page, the attendance upload, and the attendance checklist. The navigation bar allows the user to navigate around these 5 pages. The most important pages in the Android applications are attendance uploads, which allow users to upload the classroom image, and the attendance checklist, which allows a user to check the attendance when the attendance report has been completed. This is the overall flowchart of the system, which started by the image capturing by the user, upload of image through the Android applications to the localhost directory, image pre-processing by the system when it detected a new image in the localhost, face detection process, and crop detected faces by the phylogenesis algorithm, extracted face features by the hawk, and comparisons of extracted facial features with the database, updating the attendance if there's any matching IDs, and if there's no any matching IDs, it will notify the users for manual recordings or deletions of attendee. Next, moving on to the results and analysis. The result analysis is going to be divided into two parts. First part is the comparisons of empty CNN and phylogenesis algorithm, and also the system performance test. The comparisons of empty CNN, one of the best face detection algorithm, and phylogenesis algorithm was done based on the ability to detect a face in various poses on FEI database or FEI database. You can see that here's the result of the face detections. We can see that based on the test, MTCNN has a better detection rate on extreme face poses on both left and right extreme poses. However, the phylogenesis algorithm perform better as it requires less time and do not need any trainings or require any pre-trained data to be installed in the software. It is much easier to be deployed in a real-life situation. Now, this is the system performance test where it is conducted using two subjects in the same class. The developed GUI shown below give administrator the access to manage the system from adding classes to powering the system. When the system is online, the user can upload the class image from their gallery and name the image with the given abbreviations. The user must ensure that the image uploaded is clear and have minimum blur to ensure that the system managed to detect the required number of faces. When the image is uploaded, it will be placed in a local host directory. When the system detected new image in the local host directory, the image will be pre-processed to reduce and mitigate the effects on uneven illuminations. The phylogenesis algorithm will locate and detect available face in the image. It will crop the system will crop the detected face image, and the hawk descriptor will extract the facial features from the detected face image and compare the features with the database. Then the student's identity can be identified. When all the attendees have been identified, the attendance can be marked based on the detected faces. As a conclusion, through the proposed system, the recording attendance task become much more easier and faster, thus eliminating the identified drawback as mentioned earlier, without the need of expensive equipment or jeopardizing the accuracies of the attendance. This helps to ease the educator in recording attendance, especially in large classroom, monitor and manage students much more efficiently as pay attendance problem can be curbed. With that, I'd like to end my presentation with thank you.